Hey guys, welcome back to the first in a series of build videos, and we're going to be building a Vertigo 2 F5J. This one's a V-tail, so we're going to be starting with the flaps, and it's a fairly standard installation, but there's a few little things we're going to go over that are different. And the first thing is that the servo arm should be mounted pointing towards the fuselage or inboard. I'm not sure why they did it that way, but that's just the way it is. If I try to shine the light on the surface, I don't know if you can see, but there's a reinforced area. There's a strip of reinforcement, and that's inboard. And then if we look at the top, you can see right where that tape is, there's a little indent that's in the mold, and that's kind of to tell you where to put the horn. And again, that's inboard. And yeah, so there's extra carbon there, and that's where we want to put our horn. So we're going to get started. I've already started mocking things up. Now I'm going with a non-standard servo. So my installation is going to be a little different than yours, but all the methodology will be the same. So I'm using KST CM509MG servos. And I really like these servos because they're lighter than, let's say, an X10. I think these are about 11 grams, and the X10 minis are like 23. But they're much stronger than an X08, and they have kind of the same size gear train as like an X10 would have. So that's what I'm going to use here. This isn't a wing mount servo, so I had to design and 3D print my own frames. And then I have an arm, or servo arm, IDS arm on it. It's the same spline as the X10 series, so those arms work. And then I had some miscellaneous servo frames, and I just cut out the bearing portion of a few of them to give me the bearing. So the frame's going to get glued down, that bearing block's going to get glued down, and then we'll run an arm there. But so the way I basically started was I measured from the edge of the servo tray to the center of the arm. And that's 10 millimeters. You can see that right there. And I carried that over onto the tape. And I used a square, basically like this. You've seen me do this before, but basically like that. Drew the line, and then carried that over to the top surface. And on the top surface, I did the same thing. I put the square on the hinge line, matched it up with the mark I made here, then drew the line. And so now we can get into cutting out the hole here for the IDS horn. Okay, so I'm going to be using the small horns. I believe there's two sizes larger than this. And I think if you were building a strong or windy model, you might want to choose to use the horn that's one step up from this. I believe it's the mid. This is the mini. And I've gone ahead and made the recess for it in the surface. You can see it right there. Yeah, it's about 10 millimeters wide, maybe 11. I just centered it on my line. And I started with a Dremel tool with one of these cutting bits, and really undersized with this, and then I did all the final work with a file. So you want to go really slow and careful because you don't want to poke through the skins, although it is reinforced here. And I did, with the file, get to the skins on the bottom. You can kind of see it there, and the top, so that when we use our epoxy here, we'll have a nice bond to the top and bottom skin, and we're not just bonding to the foam. That's really important. Okay, so that's good. We're done with that. The next thing I'm going to do is flip it around, and we're going to have to come in here and cut a channel for the arm. So we're going to cut an opening here, and likewise we're going to cut an opening here, and I'll just cut through the carbon on both sides, and then I'll go in with a file and start removing the foam. So I've jumped ahead slightly. I have gone ahead and installed the horns. See them there. See, there's plenty of epoxy in the pockets. The positioning of the horn this way and the depth, you know, honestly, I just eyeballed. Just from experience, I'm pretty sure that's going to work. But if you want an idea, for these smallest horns, you can see the edge of the cross brace is protruding about 1.5 millimeters from the flap surface. So that will give you an idea of my positioning this way. And then the height, it's about 1 millimeter under the skin there, and that clears the top skin of the non-moving part. And then I also went ahead and cut the channels for the arms, and there's also little reliefs there the camera would focus, or recesses for the horn to go into when we have up aileron. So happy with all that. For the channels, I just marked everything with a paint pen, and then went in with my same Dremel tool bit and just started it on both sides, and then used files to complete it. Combination of a flat pointy file, square file, and also a round file. That's how I made those. So the next thing to do is to figure out what size linkage arm or push rod or whatever you want to call it we're going to use to get the right positioning for the servo, which will fit in something like that. So we're going to have to do some trial and error there to figure out the lengths, and then we can move on to gluing the servo in. We're going to scuff this up really good, clean it all off, and then mount the servos. Ready to basically get the servos epoxied in, and I got, as you can see, I have an arm in here. This is for the other side, and the arm is in this way. So this hook here is at the control horn in the flap. See that like that. And I did kind of grind off the little rib on it. I know that's structural, but I don't think we're going to be overstraining that in this light application. So servo bay is scuffed up and cleaned on both of them. And I have this one hooked up on the flap, ready to epoxy. So I'm just going to prep this other servo and get it in with the arm, and then we'll use some really slow cure epoxy and some weights and get these servos kind of wrapped up. And then we can go on to wiring. So I have the servos in place. They've been epoxied in. This is actually the next day, so the epoxy should be cured, and I have some brass slugs that were left in place overnight to hold everything down. So as you can see, I have both panels right next to each other, and I did that just to get the flaps matched up with the full down deflection as close as I possibly could. So theoretically we have the same amount of down travel there. And you can see the tapes holding the flap down, and Again, I installed these in the full down position because that's always how I do my flap builds, just so I ensure that I get the amount of flap that I want. So anyway, the epoxy is cured, so we'll remove the brass and the tape and we'll see what our throws look like on the servo tester. Here's my servo tester hooked up to the flap servo there, and let's just check our travels. Plenty of down flap, lots of up travel, so really happy with the throws. And in the center position, just to show you the offset, that's actually what the center is. So when I plug it in and power on the model, that's where the servo is going to go, and I'll have to sub trim it back to get it level or neutral. But that's how I get all the down travel. So if you centered it there, you'd only be getting like that much down travel. So something to think about. And I'm not sure if I forgot or if I mentioned it, but I did shorten the wire on both the servos because they were pretty long, so just saving some weight there. And now the next thing we're going to do is start the wiring. Here's a multiplex connector that we're going to put in this pocket. Goes in here. And there is a little bit of kind of carbon flash we're going to have to clean up on the walls in this recess. And there also is a ledge that the connector sits on, so while I clean up some of the flash that's kind of protruding this way, I don't want to get rid of that ledge, so we'll do that. And we might hog the foam out just a touch bit more to make clearance for our wires there. This is the wire that's provided in the kit, and it's actually really high quality wire. I would say it's probably 26 gauge, very flexible, very soft. So yeah, definitely use that. I'm using it, and this is what we're kind of dealing with here. I did deburr this pocket a little bit, and I removed some of the foam underneath, and now that fits flush where it should go. And this is the beginnings of my wiring for the center panel. So I'm going to be using the Jetty system, the EX bus or X bus. So I'm going to be using, well, I'm not going to be using that much wire, let's say. So I have one main power wire going all the way to the tip panel, which will be out there, and then right here I've spliced in to that wire that goes all the way across. I've spliced in positive and negative to go to my flap servo, and then I have another single signal wire, the white wire, that'll go to this connector. So we have a total of just 4 wires going to this connector here. And then when we get to the tip eventually, we'll have one lead going to the first servo bay, and in that servo bay will be a tiny little PWM converter, and the servo will plug into that, and then there'll be another 3-wire bundle, signal positive negative, going to the next servo bay. So pretty clean wiring here, should be fairly lightweight. But yeah, I just got to repeat this for the other the other half of the center panel, and then we'll start thinking about soldering up to the multiplex connector there. So the wire's in place in the center panel. You can see it coming out here. There is a hole at the root, and that allows you to run a piece of thin wire in here, and then you could tape or fix the servo wire onto it somehow and pull it through. And that's what I did. Then here we have the servo with the pigtail that's spliced in, and then the remainder of the wire out there. So we have to put connectors there. This will get a Dean's 3-pin, and over here we're going to put this multiplex connector on, and you can see that I've already scuffed it, sanded it where it gets glued. And I've actually trimmed the solder tabs down to about half. And I'm going to try to solder my wires kind of on at a 90-degree angle. And then instead of using shrink tape, I'll probably use silicone or something to insulate the connections there. So we're going to go ahead and do that. I'm not going to glue it in permanently. We need the fuselage for that because we want to make sure everything fits perfectly, but we can get it soldered and kind of ready to go. And then over here, we're going to put a Dean's 3-pin, and I just realized that I probably should have waited on fishing this wire out until I opened up this channel, or the hole, for that Dean's. So I think this was premature on my part, so I'll have to probably pull this wire out again and then open up this hole and then get the wire back going through. I managed to get the hole enlarged for the Dean's 3-pin, and as you can see, I've soldered up the wires to that. I went negative positive signal like a servo cable, but you can wire it up however you want. And if you'd be using a non-S-bus or X-bus setup, you'd want to go ahead and use a 4-pin connector there and not a 3-pin. And he does provide these connectors with the kit. They seem to be reasonably good connectors. So you could use these. They're very light, kind of big, but you could use these or a Dean's 4-pin, up to you. But we only need a 3-pin here. So I also scuffed up that connector so it's ready to bond. And that's basically one of the last steps we got to do. Test fit this servo cover. All 3 servo covers are different sizes, so keep that in mind. I don't know why. I just put some electrical tape around my connection here and used a little bit of double-sided tape to hold that against the sidewall. Got our wires there, so we're going to put this on with some black pinstripe tape, and we're going to bond this in with some epoxy. And we'll leave this loose for now, so we might not actually bond this in until we start working on the fuselage, so we'll see how it goes. Okay, well, I skipped ahead slightly, and I already went ahead and glued the 3 pins Dean's plugs into the center panels, and the epoxy is dry. And for that I used a couple of pieces of Mylar. And you can see I have the holes in there for the 3-pin connector. So this is the other side of the connector, and you know, it goes through the holes like that, and then the Mylar is held in place with this masking tape, and this other side of the connector sandwiches everything together. And before I did that, I used mold release wax and generously applied some mold release wax all around this area so that none of the epoxy would stick to the outer surfaces of the wing. And I even went up around on the top and bottom surfaces of the wing a little bit. So we should be able to just pull the tape off. I always fold over the ends of my tape so I can lift it up easy without digging my fingernails into the wing. I'm trying to do this one-handed as well. Okay, so the tape's almost off. There we go. Okay, so now the plug should just pull out. There we go. And then the Mylar comes off super easily. I did put a little bit of wax on both sides of the Mylar, but you probably don't need to. Then we have some epoxy that oozed out, and that just comes off really easy with your fingers, or you can use an X-Acto knife. So we'll go ahead and we'll clean that area up a little bit and make it look nice and pretty. Okay, so there is what the Dean's plug looks like with the epoxy cleaned off, chipped off. So that's looking great. That's all done. Just gotta rub off some of the wax there, no biggie. And then if we come down here to the multiplex connector, I did put some black RTV silicone on the solder joints instead of shrink tubing, and that's just to make it more low profile, so it still goes in and seats well without hitting the top surface of the wing. So again, we're not going to permanently glue that in yet. We're going to wait till we have the fuselage kind of set up a little bit with the harness made for that on the fuselage side, and we'll use that to glue these in, kind of like a jig. Servo covers are on. I don't know if I went over that or not, but I just used some black pinstripe tape. Kit comes with pre-cut carbon servo covers that fit real nicely. And I think that's going to basically wrap it up for the center panel. We're pretty much done. Just got to do that multiplex connector. So we'll move on to the tips, and I hope you guys enjoyed the video, and we'll see you in the next one.